Last time I demonstrated how we can create graphs of our refined projects in Profex and how we can export them to a vector drawing program for further processing. However, sometimes we would prefer to import the graph data in another data processing program instead of a drawing program, for example in a spreadsheet software like Excel or in a statistics software like Origin. It is indeed possible to import the graph data from Profex in these programs, but it requires some manual steps. In this video I'm going to show how we can recreate a graph of a diffraction pattern from Profex in Microsoft Excel. This is the graph I would like to recreate in Excel. And the data we are seeing here is coming from the diagram file, the one we specified in our refinement control file, here with the diagram keyword. It's a file with the extension dia, and this is a text file that is fairly simple to read. We can open it in a text editor. If we go to Locations, Current Project, we locate the dia file, and we can choose Open With and select the notepad from Windows, for example, or any other text editor. And this is the content of the diagram file. After a heading line, we can see the first column with the 2 theta positions of the measured data points. And then we see the intensities of the measured scan, the calculated one, the background scan. And the last 3 columns are the 3 phases in our project. That would be structure 1 is Whitlockite, structure 2 is magnesium oxide, and structure 3 is hydroxyapatite. The difference curve is not part of this file. It is calculated on the fly from the difference of the observed and the calculated pattern. The easiest way to get all this data into Excel is to simply highlight on the entire content with Ctrl-A, copy with Ctrl-C, and then go to an empty spreadsheet and paste it in an empty cell. Now it is not yet split into different columns, so we have to do that manually. We highlight the first column with all the text content, go to Data, select Text to Column, and we choose Delimited because we want to use the space characters in between as the field delimiter. So we select the space, not the tab, and Finish. Now we have our 2 theta values in the B column, IOPS in the C column, iCalc in D, the background, that was Whitlockite, magnesium oxide, and hydroxyapatite. I will delete the first column, which is empty. It contains the file name, so in case you want to keep it, don't delete it. I don't need it. So delete, and I want to use the correct headings. So now I can just insert a chart. I select the scatter chart with only lines, and here I have my diffraction pattern graph. But there is one important difference with this representation compared to Profex. If we look at the graph in Profex, we can see by zooming in that the phase graphs, the phase contributions, for example HA, are plotted not at the 0 line, but at the background curve. In Excel, if we zoom in here, the phase contributions, the hydroxyapatite is drawn at the 0 line. Same for the yellow one, which should be Whitlockite and MgO. So we would like to have them following the background. So we have to add the background to these 3 phase contribution graphs. And we have to do it by creating another column for each of the phases. We want Whitlockite plus background, MgO plus background, and hydroxyapatite with background. So instead of using this column, we just drag the selection here. And same for Wittlockite and MGO. Let's adjust the scaling again. I want to use fixed range for the x-axis from 10 to 80. That's the range we measured. We also don't have a difference curve, so we could insert it, for example, before the phase contributions. And we simply calculate the observed intensity minus calculated one. And now we can add it to our chart. We select data, add a new data set for this. And now we have the difference curve here. However, again, comparing this to Profex, in Profex the difference curve is displaced a little bit down, so it's not drawn at the 0 line, just to have a bit better separation. We can do this here simply by adding an offset of, let's try 500 counts. Maybe it's not enough. Let's make it 1,000. So now we have all the scans drawn, pretty much as in Profex. But the Profex chart also has these HKL line positions here. And we can also recreate them in Excel, but the process is a little bit different. We have to copy this data for each of the 3 phases from Profex to Excel. First, let me move this chart to a separate sheet, because we will need this space here. So now the chart is on a separate sheet and my data is still here. In Profex, we have to select the first phase scan, and we right-click in the plot options and select Copy HKL Data. Now the positions and some more information of these Wittlockite HKL lines are copied to the clipboard. We go to Excel and select Ctrl-V to paste it here. So it gives us the name. The angle, well, this is wrong. This is actually the D value, not the 2 theta angle. And this is just the number of the phases of the Wittlockite phase. And it gives us the labels, the HKL, the Miller indices, and the texture factor. We are currently only interested in the position. So we keep the D position, just so we don't confuse it. I will add the phase name. But our axis in the chart is not in D values in angstrom, or nanometers, it's in degrees 2 theta. So we have to convert D to 2 theta using the Bragg equation. And for that we also need our wavelength of our X radiation. And the equation is the following. So what I entered was basically the Bragg equation. So it gives us the 2 theta value. It's rearranged from the normal form lambda equals 2d sinus theta. But I just have to make sure when I enter lambda, the wavelength, I have to use the same unit as for the D values. And since our D values are given in nanometers here, not in angstrom, I also have to enter the wavelength in nanometers, and for copper, K alpha 1, this is the value in nanometers. And I also have to convert the angle I'm getting from the arcsine functions from radians to degrees. That's why I multiply with 180 divided by pi, and this gives me theta. I want 2 theta, so I multiply with 2. That's why I'm using 360 here instead of 180. Now we do the same for the other two phases. So we go to Profex, copy HKL data, MGO, paste it here. We don't need all this. And we can just copy the equation we used here also for this phase. Now we have the positions for the x-axis, and for the vertical axis, so the vertical position, we just want to place them at some constant value up here. So we enter an intensity value somewhere above 30,000. Let's start at 31,000, and I will use the same value for all the following rows. So I can just enter the first one and they all change if I want to adjust this vertical position. So here let's take 33,000. Okay, now we have all the data we need to draw these tick marks. We go to our chart, select data and add a new range. And for now it is just drawn as a horizontal line. Before we fix it, we will add the other two phases. Okay, now we have 3 horizontal lines at these positions, and the first thing we do is we hide the line and instead show markers. In the marker options, we can select different types, but unfortunately in Excel there is no vertical line. So we would like to have a vertical line only, because that's the standard way of marking these positions. So we have to use a little workaround to get a vertical line at each position of a marker. And for that we go back to our data sheet. And what we have to do is we insert a line from the shapes menu, a vertical line somewhere, just a short, make sure to hold the shift key so it's really vertical, a short line here, and we need 3 of them, so we copy and paste it twice. And now we can select the style, the color and the width we would like to use for the tick marks here. So for the first line, I select yellow for the color. That one I will leave at the default, and I will use green, some medium green for this one. Now I have to select the first one and copy it to the clipboard. Control C. I go to my chart. It's the yellow one. It's Whitlock height. That was this one. I select one of these markers and just hit paste and select yes. Now it uses the object I had in my clipboard at the positions of the markers. I do the same with the blue one. That was the MGO, this one in the middle. Select and paste. And the green one for hydroxyapatite. So this is looking a lot more like what we're used to in Profex. If we want to change, for example, the length of these lines, they are fairly long now, but if I would prefer to have shorter lines, I would have to shorten them here. Maybe I have to zoom in a little bit because I can barely control it anymore. So shorten. And now I have to copy and paste them again. Simply select these here and paste. And now maybe we could optimize the vertical position a little bit, move the bottom one up a bit and also reduce the spacing. Let's try this. That looks quite nice. Now to further improve this chart, we can, for example, remove the title. I also prefer to have thinner lines. So they look quite bold to me. I will reduce of each series. I also want to use our standard colors. So I want to use black for IOPS, plain red for iCalc. Then we have background, it's usually blue, and the difference curve gray. Okay, now we can actually recognize the noise pattern and things like that. I also want to get rid of this grid. And now we have to fix this, the x-axis mostly because it's overlapping with the difference curve. So I select the y-axis because this is where I can control the position of the x-axis. So in the format axis page, I can change where the horizontal axis crosses the vertical one. And I want to move it down to, let's move it down all the way to -5,000. Now, since the axis is down here, we don't have a line at 0 intensity. In Profex, we have a line at 0, a solid line, and a dashed line at the center of the difference curve. We can add both in Excel. Maybe there's an easier way, but what I do is I simply create a dummy data set from 10 to 80 degrees to theta at a constant angle at 0, intensity at 0. And another one with the offset we gave to the difference curve. The difference curve is shifted down by 1,000 counts. So I enter minus 1,000. And now I add two data ranges. The first one at the intensity of 0. And another one. Now I have two lines here. And I can again select the black solid but thinner line for the 0 line. And another black but dashed line at the center of the difference curve. So this is looking quite decent. We should add tick marks to our axis. And also I don't think gray is a good choice for something that will be printed in a publication. So let's change this all to black. And then we want to add titles to both axes. Vertical is intensity in count, and the horizontal axis is the diffraction angle in degree to theta. So insert symbol. So this is quite a nice graph. Maybe for a publication I would use different colors. The yellow or orange would not be a good choice. But other than that, maybe adjust the offset of the difference curve a little bit. If we change it here to -2,000. We also have to change the center line we just created. But this is a quite nice result. So I think some of you might prefer to have it in Excel because we can still shift it around easily. Most of us are more familiar with Excel than with drawing programs. But as you can see, it is quite a bit of work. Considering that it will probably be used for a publication, it's probably worth the investment. If you use another spreadsheet program, for example LibreOffice, it will be pretty much the same. I'm not sure if pasting the vertical lines to the markers will be the same. As far as I remember, if you use Origin, they already have a vertical line as a marker option, so you simply select this as a symbol for markers and you're done. Origin is actually a very good solution for drawing graphs like this. They look quite nice by default. Thanks for watching. If you have any comments or suggestions for future videos, please let me know in the comments below. And if you like the video, please share it with your friends and colleagues. And I hope to see you in the next one. Bye bye.